Hi guys, BuildZoid here, and today we're going to be taking a look at yet another memory overclock, as you can probably tell from, all of the memtest instances running. But, yeah, so for today, the setup is, of course, the MSI X570 Godlike. Thank you, MSI, for providing the board. I'm not using this board because it's necessary. I'm not sure that it's necessary. It might not be necessary. It just happened to be on the test bench. And so I did this overclock with it because, well, it was already set up. So that's that's how a lot of things get done here at AHOC. Is just like, well, we're using this board because that's the one that's the least work to get around to. Yeah, so let's talk about the actual memory kit, shall we? So the memory sticks in the system right now are, again, these ViperSteel 4400 CL19 DIMMs from Patriot. Could get, yeah, so 4400 CL19 from Patriot. A2 PCBs on all of them. Basically, I recently bought a second set, so thank you, patrons, for, funding that. And, well, since now I have 4 of them, I may as well run them in, a 32 gig configuration here on the 3950X. So, also speaking of the 3950X, thank you, patrons, for that as well. Yeah, so it's been running memtest. The fan is actually necessary for this overclock. At a slightly lower frequency, you can get away without the fan. At the same timings, same voltage, same everything. Because the funny thing is like, as you crank your frequency up, the fan the cooling requirements go up with the frequency. So at higher frequencies, you need more cooling. So that's why the fan is there. Because if we drop the frequency down, then I can actually take the fan off. But yeah. So yeah. Oh, right. I should have probably mentioned that this is, of course, Samsung B-Die, but I'm assuming that if you're watching this video, then you already know that 4400 CL19, because these are 191919, it's not like 1923 or something, right? So this is proper, like, B-Die memory here. And the great thing is about, at least in the UK, these DIMMs are still really, really cheap. You can get them for, like, I think around 120 quid right now. Which is insane because if I wanted a comparable, well, anybody kit, like, it doesn't even matter. It could be G-Skill, it could be Corsair, it could be, well, actually, Team Group can sometimes get into, like Team Group's like the next step up in terms of price point from the Patriot kits, but, like, these are ridiculously cheap for what they are. So, yeah, and they also happen to be some of the best, well, I've not yet tested the new set in, like, a just as the sticks themselves setup, but yeah, so, like, I'm pretty sure this is 2 more of the best V-Die that I own. So yeah, also the original set of these DIMMs that I got, those don't have heat spreaders on them anymore, because the heat spreaders, like, what I will say is the heat spreaders on these, as nice as the memory stick PCBs and the memory chips are, the heat spreaders are kind of terrible. So I actually pulled the heat spreaders on the first set. I'm not sure if I'm gonna pull the heat spreaders on the second set. I might end up doing that anyway, but yeah. So half of these are without heat spreaders. And anyway, let's take a look at the overclock and everything. So yeah, this is the fastest I think I've run B-Die for Ryzen as an overclock. So yeah, we've got, I think, 27 instances of memtest. Each of them is 1200 megabytes. They've now passed almost, some of them are at 500%, some of them are going to be a little bit below that. You can see that we're using basically all of the available system memory, as there's only 377 megabytes available for anything else to run in. So yeah, like this is a like the thing is, I had a failed take of this video earlier today, which meant I spent several more hours waiting for memtest to pass because I got a plan. Like, I got some real plans when it comes to shooting videos. Anyway, so yeah, so now it's up at 500%, and I'd honestly consider this daily stable. It passes IBT, it passes Prime 95, it passes memtest. Like, there's nothing you can throw at this that'll, well, okay, that's, I'm sure you could write something that just causes a crash on purpose, but outside of that, I don't think there's anything that'll I can't, well, it passes IBT, it passes Prime 95, and it's not like wimpy Prime 95. No, it's small FFT's Prime 95. So, as well as like a higher memory usage, though that's primarily like IBT's job here. Because funnily enough, if you set the memory usage high enough in Prime 95, the power consumption comes down significantly. Whereas in IBT, well, IBT basically pulls the same amount of power regardless of how much memory it's using. So that's kind of like, it's not like the peak heat output of IBT is actually a bit lower than small FFT Prime 95, but IBT can chew up a lot more memory at the same time as getting very, very hot. So, yeah, that's why I like using IBT. It makes for a good Infinity Fabric stress test because you have a lot of memory usage at the same time as actually having everything pretty warm. Anyway, so yeah, mem test is finished up here, so I'm just going to close all of these instances. Because at 500%, like, I would honestly consider this dailyable. Well, if... Actually, no. Honestly, after 500% of memtest, I wouldn't bother, like, running memtest overnight. I just wouldn't bother. Especially, like, it also did, you know, almost half an hour of IBT. Now, IBT I might run instead of just half an hour, I might go all the way to an hour. And then also do, like, an hour of Prime 95. And be done with it. But it's already, like, I've passed an hour of Prime 95 in the past on this. So, that's mostly related to the CPU overclock. So, speaking of the CPU, the 3950X right now is actually running a static overclock, so it's not a boost. Like, basically, there's no single core boost on this anymore. In fact, the single threaded performance is really quite low because of my criteria of like this needs to be able to run Prime 95 and not overheat and not crash. The voltage that this is currently running on the CPU is rather low. And that does mean that the frequency that it can achieve is also rather low. And the end result overall is just like, well, IDA's, for example, memory latency test is actually single threaded. In fact, because what I did with it once was, so the bandwidth tests are multi-core, but the latency test is, as far as I can tell, completely single threaded, because when I was trying to minimize the latency on my 3700X, it also scales with CPU clock speed. So when I was trying to minimize the latency on my 3700X, one of the things I did was I had it running like 2 cores with no hyperthread, with no simultaneous multi-threading, and just stupid amounts of voltage because my 3700X sucks. So even with like 1 core and no simultaneous multi-threading, that chip needed like, I think it was like 1.45 volts or something stupid. Like that chip's just junk. So anyway, yeah, so right now we're idling at like 1.337 volts, but the thing is this does have a lot of droop on it. So if we just hit it with small FFTs, it immediately drops down to around 1.22, 1.23 volts, which is exactly, like, that's in line with what the actual CPU will run if you max out the PBO limits to the extent that you can max them out. Because obviously if you punch in like 999,999,999 for all of your power restrictions, PBO glitches out and Prime 95 power throttles like crazy, and you end up with like 1 volt in Prime 95, which basically means like, yeah, it's broken, and power throttling. So anyway, this doesn't power throttle. It does get insanely hot, so we won't be like, admittedly, when I was doing the Prime 95 test for like doesn't overheat, the room was quite a bit cooler. So yeah, right now I'd say the room temperature is very, very comfy, which is probably about 5 degrees warmer than when I was doing the Prime 95 thermal tests, where I was like, yeah, as long as it doesn't overheat. Because the thing is, it's pulling like 285 watts right now, so yeah, it's really hot. So we're gonna just stop Prime 95, some latency tests, and also I still haven't mentioned the actual settings. So FCLK is at 1900, memory is at 3800, 14, 16, 13, 27 primaries. I mean, you can see the timings right there. But yeah, so this is 3800 CL14 at 1.5 volts, which is why the fan is necessary. If we were at 3733 with CL14, the fan wouldn't be necessary any longer. But at 3800, the fan just... Because without the fan, I'd be getting memory errors after around 200% of mem test, which basically means like, yeah, it's overheating. So now it has a fan, which I like. The thing is like some people might be like, the fan is cheating and not practical for a daily system. And my response to those people is like, I've been dailying test benches since like 2013. So no, the fan is completely practical, and test benches are very valid ways to run your daily system. Anyway, so let's run the memory latency test. The issue here is, since the CPU is at only 4.35 gigahertz on the fastest set of cores, mostly because like it needs to be stable at 1.22 volts, the latency kind of sucks. Like if we were running at 4.7 single core, the latency would be maybe even a full nanosecond lower. But yeah, I don't actually, care. So... Because the thing is for, like, in the current configuration, the system is faster for all heavy multi-threaded workloads. Even Cinebench, this is actually slightly faster than the best set of settings I've run in, that I've managed to get out of Precision Boost Overdrive, which the highest score with this motherboard and this, like, with the cooling system that's currently running here, which this is on liquid metal, which is why I can get away with the Prime 95 runs. Also because I can't be bothered to remove the liquid metal. That's the main reason why it's still there. Yeah, the thing is for Cinebench, PBO will max this out at around like 9,780. Right now, this spits out a little bit over 10,000. Again, if I wasn't going for like, the thing is, I could probably run Cinebench at like 4.45 gigahertz. Well, on the first CCX could probably do that. The rest of them I'm not sure about, but the first one can probably do 4.45. But the issue is just like, it won't be even remotely Prime 95 stable. Anyway, so memory read speed is basically maxing out the theoretical limit for 3800, because the theoretical limit for... And this is a really easy calculation. So we have a dual channel, so each memory channel is 64 bits wide, and you can transfer, well, the thing is that, like, when you say 40, like, when you say, like, it's really dumb, because even the memory sticks have it on their packaging. Like, it says 4400 megahertz on the packaging of these memory sticks, but that's 4400 mega transfers, not megahertz, because memory is double data rate. So the actual clock speed of a 3800, like this right now is running DDR4 3800, which is not 3800 megahertz, that's 3800 mega transfers. Anyway, it doesn't matter. Basically, you can multiply the effective data rate, right, which is 3800, by the bus width of each memory channel, which would be 64 bits, but we're going to just divide that down into bytes anyway, so that's going to be 8, and then you have 2 memory channels, so times 2, so you can just do 3800 times 16, right, because that represents our 8 bytes per memory channel and both of our memory channels, and you get this. So the absolute maximum memory bandwidth you can do at 3800 is 60... 60.8 gigabytes per second, essentially. And we're getting about 60.2. So this is, like, the timings couldn't really get any tighter. Obviously, there's also the advantage of, like, this is dual rank, so, because we are running two sticks on each of the memory channels, and each memory stick is a single rank, because BDI is an 8 gigabit IC, these are 8 gig sticks, so you got a rank of memory per stick. Anyway, write speed is a bit lower. I think if I fiddled with the timings a bit more, I could probably get a little bit more write bandwidth, but honestly, at this point, I think that's just, like, not necessary. Like, this is already so very, very... Like, these are by far the most aggressive memory settings that I've gone ahead and, like, fully mem tested. So I'm just, like... Because even, like, the tertiaries on this are actually tightened up, which I normally don't bother with. So yeah, we get about 58 gigabytes per second for write, which is still really good. It's like, it's not as nice as the read speed. And then I think copy will probably spit out something that isn't realistic. Like, it'll violate the theoretical maximum. Anyway, so, like, the thing is like, these settings make me, like, the current configuration of the system in general, not just the memory, like, also the CPU, the fact that everything's Prime 95 stable, the fact that it's relatively cool. Yeah, so we're getting, like, 64 gigs copy, which is just not physically possible. Like, there is not enough clock cycles between the memory controller to the memory to transfer that much data. So, yeah, IDA's, like, that's basically IDA's copy test not working, like, properly. Because I'd assume what's happening is it's actually picking up cached data, and it's interpreting, like, cache bandwidth as memory bandwidth, which is just like, yeah, you're not supposed to do that. And that's why you can get a copy that is higher than the actual maximum data transfer rate of the actual memory sticks. Like, there is no way you are moving that much data at 3,800 mega transfers per second across a 64-bit, across two 64-bit wide memory channels. Like, you can't do that. It doesn't fit. So that's just the test not working properly. Anyway, if we run Cinebench, so yeah, compared to Prime 95, Cinebench is an absolute joke in terms of both power consumption and temperatures. Like, yeah, it pulls about half as much power. Oh, okay, no, it's doing 200 watts now. Half as much power would have actually been concerning, because it should be about 20% more in, well, okay, that's interesting. So the Prime 95 was doing like 280, which is more like 40% more than Cinebench. But, yeah, so I know, like, Cinebench R20 is supposed to be AVX accelerated. It's just not very, it's not very heavy on the AVX acceleration, so this is on the low end, but, you know, Cinebench also has a bit of variance to it, so if you rerun it a bunch of times, the score goes up, which is great as well. Actually, I'm not sure if that 10223 in that table there is on stock. Well, yeah. It's a shame Cinebench doesn't log frequencies properly. But yeah, like, this whole setup, like, it's like, it passes every stress test I care about passing. It's fast, right? For multi-core workloads, it's really fast. But the thing is like, well, personally, I don't find that I like, well, I do play Minecraft, but the thing is, I have literally, I have a Ryzen 7 1700 as my daily setup, so it's just like, even if this was running at just 4 gigahertz all core instead of 4.2 plus, across the board, because the slowest CCX is at 4.25, so, like, even if this was running just 4 gigahertz, it would still be a massive upgrade over my daily system, but I need the 3950X for making, you know, videos and stuff, so it can't go to my daily system. But I'm really happy with the, like, it wasn't even my intention. Like, at some point I was kind of toying with the idea of doing like here's how to set up like a really, like, here's an example of a very stable, static Ryzen overclock with, like, maxed out memory, maxed out absolutely everything. And which, again, like, if you weren't testing with Prime 95, you could max the CPU out higher. But then it's, like, I don't know. You know, it's your system. My personal preference with stress testing is, like, it shouldn't crash in anything. And I'm not, like, there are some people who will run stress tests for like 24 hours, which I think is really excessive. But for me, it's like, I shouldn't have the system just up and die after like an hour of Prime 95. That should not happen as far as I'm concerned. So that's my test criteria. Anyway, so let's go through the settings. So yeah, it's a per CCX static overclock. Gotta say, I really like the way MSI has the per CCX overclocking implemented. Like, it's very easy to know, like, figure out where it is compared to some other motherboards where it's just like, wait a minute, what? Where it's kind of buried somewhere. Anyway, so yeah, 3800 on the memory, 1900 FCLK. For the voltages, these are not minimized. They're kind of just like they're safe, but they're not minimized. So what that means is like they're not high enough to do damage, but they're not necessarily as low as they could be, because I don't really care about saving a couple watts on the IO die by lowering the SoC voltage a little bit. Like, it just doesn't matter to me. So yeah, that's why the IO die is at 1.15 volts, and both of the VDDGs are at 1.1, because that's not going to break anything. Yeah, and the FCLK at these voltages is actually stable for IBT, for mem test, for everything. Because the thing is, if your FCLK isn't quite stable, what you get is like, well, actually, in general, Ryzen, if it locks up anywhere on the CPU, it just shuts down the entire system immediately. You don't get any, like, you don't get a warning, you don't get a blue screen, you just get, oh, look, the system's not running anymore. And that's normally like, oh yeah, the FCLK just died. Well, the Infinity Fabric just hit an error, and it doesn't seem to have any correction system, so when that happens, it just shuts down on the spot. Anyway, yeah, so that's at 1.15, and I'm just not interested in like because I could work that voltage down, but then it's like you lower the voltage a bit, do a stress test, lower. Well, actually, no. What I would do is I'd lower the voltage until it stops posting, then I'd start raising the voltage until it starts passing stress tests. Because the other direction, if you lower the voltage 10 millivolts and then run a stress test, and then you for an hour, and then you go and you lower the voltage 10 millivolts and run a stress test for an hour, like that's just gonna take for freaking ever. So, no, you first go so low that it's definitely unstable and then start working out. Like, it's easier to, like, if it's stable, proving that it's not stable is going to take an infinite amount of time. But if it's not stable, well, it's very likely to crash very quickly. So, that's kind of that's how I would minimize the voltage if I actually cared about doing that, because that is not high enough to cause, well, that might cause issues with PCIe 4.0 devices, but, well, I don't have a 5700 XT, so I don't care. So that's kind of that. Anyway, so this might be unnecessarily high. The thing is, with the SoC voltage, that voltage actually feeds the regulators that are built into the CPU, into the CPU pack. Well, I'd assume it's in the dies. So, anyway, there's voltage regulators built into the 3950X that actually produce the VDDG voltages, so the VDDG CCD and VDDG IOD. Those are generated on die, and they are generated from the SoC rail. So if the SoC rail is less than the your VDDG voltages have to be at least 40 millivolts below your SoC voltage, because those regulators, the minimum amount of the minimum amount that they can reduce the that they reduce the voltage by is 40 millivolts. So if you want to feed the CCD, the VDDG with 1.1 volts, you need at least 1.14 SoC to do that. If you set 1 volt SoC, or 1.1 volts SoC, then you're going to get like 1.06 VDDG, regardless of what you punch into the BIOS, because those regulators literally can't, like, they can't boost the voltage above what they're being fed with. They can only step it down. So anyway. These might still be unnecessarily high, but they're not going to damage anything, so I'm completely cool with running that. 1.5 volts on the memory, which is actually necessary. I wouldn't pay too much attention to the BIOS voltage reading. Software voltage readings tend to be horrifically unreliable. And also, like, even the BIOS itself doesn't agree with itself. Like, up here by the mouse cursor, which is horribly laggy and terrible because you shouldn't be forced to use a mouse in a BIOS. Yeah, that says 1.504, and that down there says 1.514. So it's like even the BIOS itself, like, there's probably two different sensors making that measurement, and one of them is just in some weird location where the voltage is slightly higher. So anyway, that's the voltage settings, right? I didn't change anything else because there's really no need to change anything else. VRM settings, quite a bit of droop. That is mostly to, like, the thing is, having some amount of droop helps the VRM with voltage regulation. So basically your overclock is going to be more stable if you apply more idle voltage and then droop down instead of trying to just force the voltage to be the same all the time. I'm not going to go into details on why that works, but yeah, that just works. So that's why I'm on mode 4 LLC, which is quite droopy. Which is why the voltage goes from 1.33 to 1.23 when we run Prime 95. Voltage protection's completely maxed out because, well, honestly, I've still never understood why we have voltage protections in the BIOS. Especially because, yeah, I don't get it. Because most of the time how they work is if you punch in a too high voltage value, then the protection kicks in, but it's just well, I guess it's for people who are really, I guess it's for situations like that. I guess that's why the voltage protections are there, but, yeah. Outside of that, I don't get why you need voltage protection settings. So those are maxed out. Overcurrent protection maxed out. Switching frequency at 600 kilohertz. Honestly, you could go all the way up to 1,000 kilohertz, but it just doesn't make a difference, and it makes the VRM run a bit warmer, so that's why I settled for 600 kilohertz. Over temperature protection is on auto, just because the VRM on the Godlike is so freaking ridiculous that it's not a concern. I honestly don't care where the over temperature limit is, because I'll be very surprised if the motherboard ever reaches it. Load line calibration for the SoC voltage is actually relatively high because the SoC does not need to supply anywhere near as much current as the V-Core VRM. So, yeah, and so that's at mode 2, which is still a little bit of droop because the thing is, going between absolutely no droop and any amount of droop from the voltage regulator's perspective is it makes life much easier because the voltage regulator doesn't it responds to changes in voltage. So it is physically impossible for a voltage regulator to maintain output, completely flat output voltage, because it doesn't know that it needs to make an adjustment until the voltage starts dropping on its own, right? So that's kind of the thing. But with the SoC VRM, so I would just not run mode 1 at all, ever. There's really never a good scenario for it because it just makes even idle transient response worse. So significantly worse. So that's why, a little bit of droop, and that's just mode 2. Because on the flip side, the SoC just doesn't have that big transients, so it's just I want the absolute minimum amount of droop, but not a flat load line, because a flat load line is just yeah, that doesn't work. And I'll probably do a video covering the theory of that eventually. Well, actually, I've shot one version of that video that I don't like, and it's just we'll see if I ever manage to produce a version that I do like enough to publish in public. Publish to the public. Anyway, Northbridge switching frequency is just maxed out because unlike the V-Core VRM, the SoC doesn't need to handle a lot of current, so I actually don't care if it's really inefficient at 1,000 kilohertz. Memory VRM disabled phase control because it makes the idle efficiency worse, but in theory it should make the overclocking better. I've not tested if that's actually true. It's just on paper this should be better for overclocking because you'll have both of the phases running all of the time. Because this motherboard has a 2-phase memory VRM, and so that's turned on because it doesn't really make that much of an efficiency difference, especially considering the memory VRM on this thing is super ridiculous overkill as well. Really just the reason why this motherboard is so ridiculously expensive that I wouldn't recommend it to just about I honestly it makes it real. Well, no, I just can't recommend it, but. One of the neat things about a motherboard that costs this much is that your memory VRM is worth more than the V-Core of a mid-range, a low-end B450. Actually, the memory VRM on this could probably replace the V-Core of a low-end B450 motherboard. So yeah, that's the SoC VRM definitely could. So it's just the board is insanely ridiculous overkill in a lot of ways. So anyway. Over voltage, under voltage protection is just maxed out again. Over current protection maxed out, which they only have auto and enhanced, which is I don't even know Why? Why isn't there just OCP disable? Which you can do. Most controllers allow you to disable all of the fault detections, which, well, not necessarily the best way to do things, but it'll stop them from tripping any kind of malfunction protection, including overcurrent. Switching frequency is maxed out for the same reason that Northbridge switching frequency is maxed out. It's a two-phase. It doesn't handle that much current. I don't really care that it's going to be slightly less efficient. And then over temperature protection, just auto, because again, I'll be very surprised if the memory VRM, like, I'm pretty sure the OTP is set to 135 at stock, and it's just like, yeah, I'll be very surprised if it ever reaches that temperature. I'll be very surprised if it ever reaches over 80 degrees, to be completely honest. Anyway, so let's take a look at the actual memory settings, because that was supposed to be the focus of the video. Gear down mode, because again, like, you know, I have tightened up even the tertiaries this time around, but I'm still too lazy to try stabilize proper 1T. Like, gear down mode is just so convenient, and it just doesn't make much of a difference to the actual performance that, yeah, I'm just going to run gear down mode because I really don't like, because the thing is, if you want to stabilize proper 1T, you end up having to spend a lot of time fiddling with like termination settings, and it's just like, well, I can't be bothered is the answer there. You might, well, termination settings and also drive strengths, like you might have to end up fiddling with both of those, and it's just like, yeah, I'd rather not. So gear down mode it is. And then for the timings, I mean 14, 16, 13. So TRCD, I would guess that this is actually a memory controller limit, especially considering that this is dual rank and not single rank, and not a memory stick limit, but I'll have to test that. Which is going to be, that's going to be difficult to test. Actually, no, I'll just do a test of like 3800, 14, 14, 14 on a different platform on like, say, my 9900K, which should be able to handle that. I hope it's able to handle that, because that chip complains with like 4400 megahertz. TRCD 16 doesn't work on that CPU. Like, the memory controller can't do it. So not for like mem test stability. It can do some benchmarks at it, but it's not going to do mem tests. So yeah, that's going to be interesting. I'm not sure if it'll do 3800 and 14 TRCD either, but that's like, I wouldn't blame the memory kit for that. I would probably blame the CPU for that. Like, TRCD in general is just a timing that is hard on memory controllers, more so than memory sticks. And if you have dual rank, well, it's even harder on the memory controller. TRCD WR is at 13. Honestly, I'm not sure why it isn't at 8, but at this point it's too late, so we're not gonna, like, I'm not. It would probably run at 8. It might improve the write performance if I set it to 8, but apparently I forgot to do that when I was setting up the timings. TRP at 13, TRAS at 27. TRP won't go below this. This is straight up minimized. Like, if I tried to run 12, it won't be stable. TRAS 27, this could probably go lower, but I just have it matched to the TRC, which normally, like, the TRC might also go lower, but the thing is, like, I think, like, there's maybe, like, 6 ticks left in TRAS, like, it might be able to do 21 instead of 27, maybe 23, 24, like, you know, a couple more ticks down on TRAS is probably possible. A couple more ticks on TRC might be possible. TRFC is also not minimized. Like, TRFC 300 is just like, it's stable all the way up to 4400 megahertz, and I don't care about the fact that at 3800 you could probably run it at like 260 or 280, because it doesn't really make that much of a performance difference. So I just leave it at 300. TWR 12 might do 10. The thing is, TWR, a lot, like, I've done some tests, well, it might just be IDA being insensitive. Like, IDA's not that great a memory test. Like, in a lot of scenarios, like, there are certain timing combinations that will really badly underperform in, like, actual workloads, like video encoding and Intel burn test, which is not a real workload, but anyway, the thing is, like, those same timing combinations that, like, torpedo benchmark scores, they don't affect IDA, which is like, good job, IDA. Like, your memory test is awful, which is why I've started, well, which is why going forward I'm going to start mixing in some other memory benchmarks when I'm doing actual like stock memory benchmarking instead of overclocked settings. Because the thing is like comparing overclocked settings, just like there's the silicon lottery, right? Which means just like well, I seem to have really good luck with the ViperSteel so far. Because this new kit seems to be at least as good as the first kit, at least at like low voltages. At high voltages, I've not tested it yet, but we'll see. Um, yeah, so where was I going with that? But yeah, if I was comparing like stock settings, like XMP profiles between memory kits, I wouldn't just use IDA because IDA will not pick up on a lot of issues that sometimes show up. Anyway, WTRS 4, WTRL 8, these don't go lower, I don't think. Or maybe I tried 3.8 and it underperformed. Like one of two options. Like I think either 3.8 was underperforming in I think IBT, or it's not stable. One of the two. And actually, it might have been underperforming in IBT because it wasn't stable. Like there are certain scenarios where like unstable timings will actually just lower your scores. Anyway, TRRDs are both 4 because that's literally as low as they go. Like you can't set them lower. 4 is the app, like the memory controller of the CPU is literally not capable of comprehending a value of less than 4 for the TRRD timing. RTP10, TFAW 16, same, like TFAW can't be lower than 16 because the TRRDs can't be lower than 4. TCWL 12, that, like, it probably won't do 10, but it could go down to 10. I just don't think the memory sticks are good enough to do that. And on some memory sticks, you might be actually like TCWL will either like normally it either does one tick, same as TCL, one tick below TCL or 2 ticks below TCL. Since we're in gear down mode, it's 2 ticks below TCL here, so it's a 12 instead of just 14. TCKE1, which I do believe, yeah, it just doesn't go any lower than that. And then for the tertiaries, we have TRRD SCL3. These are at 4. That's at 3. The other SCL is also at 3. These are at 6. And then we have a 1 at the very end there. This one can probably go lower, but too late now. Like, I'm done with this. Like, this is already, like, at this point, the only performance metric I think that could improve a little bit is maybe the write performance a bit. And, and these other ones that I left alone, I'm not... Yeah, those, like, you can't set them to 0. And they're on auto, they're already 1. So, it's just like, yeah, that's why I left those alone. Anyway, so, yeah, that's the timings here. I would not recommend that you copy-paste these, as they will probably not work. But these are, like, goals. So, you know, this is kind of the thing you should work towards too. Though, for the secondaries, if you have B-die, from the TRFC down to the, like, well, the RTP I would probably not try to, like, that might not work. But, everything else, like TCKE, TCWL, TFAW, TRD, well, TCWL you might want to, like, TCWL will depend on your TCL, but, TWR, WTRS, WTRL, TRRD, TRD, well, S and L, TFAW, those you can pretty much copy-paste, as well as the TRFC. If you have B-die, that these should work, because, like, and I'm basing that off of the fact that basically, literally, well, all the good B-die I have, I just punch this memory, these timings in, and that's like my baseline starting point for any kind of memory overclocking is just 300, 4, 8, 4, 4, 16, and then TCWL based on whatever TCL I'm running at. As in, you know, if we're running TCL 16, then TCWL 16, 15, or 14, depending on the platform and which exact memory kit it is. So, yeah, that, I think, is everything. And then for everything else, I just let the board do its own thing, because it's pretty, like, evidently the auto, like, it's passing memtest, it's passing IBT, it's passing Prime 95, so the auto settings are doing a perfectly good job of stabilizing things for me, so I won't mess with them. Though, potentially one thing that might be worth doing is using Ryzen Master. So if we quit without saving, using Ryzen Master and just, like, writing down all the different actual like sub configurations and then punching those into the BIOS manually, so that if because sometimes if you do like a cold reset, like if you reset the system or cut AC power, right, so like unplug the power supply and then power up the system again like a couple days later, you can sometimes run into issues where the motherboard will basically, like all of the stuff that I left on auto, it might forget what the correct auto values for that are. And then a very stable memory overclock can go from very stable to very unstable without you actually doing anything. Like you'll be like, but I didn't touch anything in the BIOS. Well, the motherboard, auto is not a fixed value. Auto is auto, right? Like it's like an automatic gear shift, right? Where it'll choose depending on the situation. So yeah, so you can see in Ryzen Master, like we have CPU on die termination right here, 36.9, so I'd copy that down, gear down enable, well, I've manually set that. RTT nom, we would copy this value, that value, this value. Then the drive strengths, which are 2420, 2424. It's interesting. That's actually a combination of settings I've tried on multiple occasions, that 2420, 2424. Anyway, so basically I just copy all of these and punch them in the BIOS just in case. But yeah, I'm honestly not bothered with doing that. So yeah, that's the memory overclock that I've managed on 32 gigs of the ViperSteels. Consider, like, they are, at least in the UK, like, it depends where you are, but in the UK, these are literally some of the cheapest B-die you can get, and, well, so far I've only had good sticks, so I am really, really happy with this set, as well as with the previous set, and I guess I guess I can show off the PCV, so, and this is one of the sticks from my original set. Because I'd assume some people haven't seen the first video I did with these, but yeah. So, A2 layout. Come on, focus. I'm not. Okay, we'll do it this. Holding it too close. There. So that's what B-die looks like. A2 layout has the big gap between the memory chips in the center, right? Where like nothing right here, and then memory chips, more memory chips, nothing. So that tells you that it's an A2. Though there is one other layout that actually looks very similar, which is A0, but there's a blank spot for an extra memory chip that's missing, because that not A0, A1. A1 has a blank spot for an ECC memory chip. Anyway, what's kind of neat about these Patriot DIMMs compared to, say, generic A2 is that these actually get a bunch of extra capacitors. I'm not sure how much those actually do. I'm not sure that I have equipment sensitive enough to like measure the differences between different memory PCB layouts in terms of even just like power delivery. So yeah, but this is not actually the only kit I have that now uses this PCB. Like I have a new, like I got another new B-die kit that also is probably really good, that also uses this style of PCB with the extra capacitors. So yeah, but anyway, I just find it interesting that like this is a very, because there's like most of the A2 until I got these Patriots, just it all looks relatively the same except for like OEM sticks, because well, basically, if you get like a G-Skill A2 kit or a Team Group or a Corsair or whatever, like they'll have a 10-layer PCB. But if you get like a OEM Samsung, you're going to be looking at an 8-layer PCB, and the end result is that you have the way the SMD components are arranged is quite different. And the OEM PCBs should be weaker in terms of overclocking, just because it's not a priority. If it runs 3200 megahertz, then it's good enough, and like that's all Samsung cares for. So yeah, anyway, that's it. It's just like that's the overclock, like 1900 FCLK, 3800 memory, CL14, 1.5 volts. Like, this is basically the limit. I don't really think, like, the only thing that I think could maybe get better is, well, I'm still not sure that it's a memory stick limit. Like, like, I'll have to test if it's, like, memory sticks or the CPU or something, but I really don't think the TRCD is a memory stick limit. It might also be that maybe if you fiddled with the termination settings, you could get the TRCD stable at a lower value. But yeah, 14, 16, 13, like, I don't think there's much room left. like, like, just in general, like, I don't think you'd be able to find anything. Like, maybe there might be some sticks that are like really crazy good that might do like 3800 CL13, but then you have to fight with the whole not running gear down mode anymore. And well, that just doesn't sound like fun to me. So yeah. Anyway, also, I'm definitely not sponsored by Patriot with these kits. Like, I'm buying every single one of them. So, yeah, I'm really, like, I'm really happy that, like, the only B-die I've actually, wait, no. Have I bought other B-die? I have. Okay, so out of, like, well, so, still, like, I'm really happy that the few B-die sticks that I've actually bought, like, they're so freaking good. Um, so... yeah, like, and at this point, like, I have 4 sticks, so I don't care if they go out of stock now. So, yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's a link to that down in the description below. And if instead you'd like to pick up some merch like shirts, stickers, posters, that kind of thing, there's the AHOC Teespring store. There's a link to that down in the description below as well. I really need to stop hitting the table and shaking the camera. And yeah, you know, the Patreon and the Teespring, well, that allows me to go and pick up copious amounts of these right here. Though I'm not going to be buying any more of these. I have 4, so I don't really do the whole buy 10 of a specific speed bin to bin them all, like to rebin them for the best ones at high voltage. But yeah, I don't really do that. Costs too much. Very boring, in my opinion, to test the same kit over and over again. So, yeah. Anyway, yeah, if you'd like to support me, there's the links down in the description, and that's it for the video. So, yeah, goodbye. I'm gonna hit the stop button now.